Now we will learn about the memory and zero hold block. So in a memory, if we want to know about the memory block, theoretical part, the memory block holds and delay its input by one major integration time step. When placed in an integrator subsystem, its hold and delays its input by one iteration. This block accepts continuous and discrete signals. The block expects one input and generate one output. Each signal can be scalar, vector, matrix, or ND array. If the input is non-scalar, the block holds and delays all elements of the input by the same time step. We specify the block output for the first time step using an initial condition parameter. So careful selection of these parameters can minimize unwanted output behavior. However, we cannot specify the sample time. This block sample time depends on the type of solver used, or like we can specify to inherit it. The inherit sample time parameter determines whether the sample time is inherited or based upon the solver selections. So here you can see I have connected a clock with this memory block, and this is connected to the scope. So if I'm simulating this, you can see the scope results here. Here that this is okay. If I want to come here, I already told you with the legend we can see which is the memory output and which is a clock output. Again, if you want to come and lay out, if I'm dividing this in a two, okay, so you can see now this is my memory output, this is my clock output. So here you can see uh, so here you can see now the clock is connected to the memory and memory is connected to the scope. So once that what that memory output contains, that clock is showing us it continuously increases, but clock is increased stepwise. Okay, that stepwise increase shown by this memory block. Memory block is simply holding what happened to achieve this. It will not show us directly the output, that whatever small step, sample step, that also it consider inside it. Okay, so next block is zero order hold. Okay, so for this zero order hold, the zero order hold block holds its input for the sample period. We specify if the input is a vector, the block holds all element of the vector for the same sample period. We specify the time between sample with the sample time parameter, and setting of -1 means that block inherit the sample time. Okay, so here you can see again I have created one model. A clock simply connected to the zero hold order, and this is connected to the scope. So if I'm simulating this, you can see in the scope. Okay, again I'm coming in a view legend. Okay, and I am making this to the layout and in a simpler. Previously in memory, it is also in that same way it will work, but it is starting with zero order, where memory is starting with first order there. Okay, in that same way this block is also work. So these two blocks we studied, but one more thing which we want to discuss is more important is here is there are the comparison with the similar blocks. What are the similar blocks and what is this and what is this? Okay, so the memory, unit delay, and zero order hold blocks provide a similar functionality but have a different capabilities. Also, the purpose of each block is different. So in the table, you can see here block name, unit delay, memory, and zero order. So unit delay, what the purpose of using a unit delay is implement a delay using a discrete sample time that we specify. Okay, the block aspects and output signals with a discrete sample time. So we have the references. We can take the instant training model. We can close loop system. We can go with that. We will get it that bit right. Yeah. Okay. So memory block is used. Like what is the purpose for that using to implement a delay by one major integration time step. Ideally, the block expects continuous or fixed minor time step signal and outputs a signal that is fixed in a minor time step. Okay, this is the purpose. Okay, so zero order hold block, what is the purpose for that? That convert an input signal with a continuous sample time to an output signal with a discrete sample time. So this is the main purpose which we can use here for this. So each block having the following capabilities in this table. You can see the capabilities like specific initial condition. Yes, memory block is having, unit delay block is having, but specify initial condition zero order hold block is not having, because the block output is at t is equal to 0 must match the input the values. Okay, where specific sample time, spatial sample time, but in memory there is no special sample time, because the block can only inherit sample time for the driving block or solver used for the entire model. But unit delay will have specification of sample timer. Zero order hold block is also having. So support of frame-based signaling, memory block will not support, but zero order and unit delay block will support. Where support of state logging, so memory block will not support and zero order block will not support, but unit delay block will support. So unit delay block will contains all the features without any limitations, but every will be having different feature and different capabilities to perform the various things in a Simulink. So that's all about this unit delay, memory, zero order block, and discrete libraries.